Let's look at this summation, which if you write it out, it's like 1 over 1 times 2 when n is 1, right? The next one is what? Then n becomes 2, so 1 over 2 times 3. What's the next term? 1 over 3 times 4. And then 1 over 4 times 5, and it goes forever. Okay. Now, this is not a geometric series because you don't get a single number to multiply to the next one. The ratio between the two terms that you pick are always different. So ratio between these two are 1/2. These two are like 3 over 5, I think. And it just changes, right? So at first, it's very hard to figure out what that summation is. And actually, it's impossible to figure out unless you know some identity, which is, do you remember when I did the integral of 1 over x times x minus plus 1? How did we do this?
Oh. So did we break it up? We broke them up. It was like a over x and then and then b.
Right.
X over 1.
So we're going to use a similar idea here. You break up 1 over n times n plus 1 as a over n plus b over n plus 1. Multiply, so you get 1 equals to a times n plus 1, b times n. Right? You multiply this to the right side, and n cancels, and this is what you get. Now what do you do?
Plug in 1.
Not 1.
Oh, negative 1. Sorry.
Negative 1. You plug in negative 1 so that this becomes 0, and you get 1 equals to b times negative 1, so that b is equal to negative 1. Now you might wonder, how can you put n equals negative 1 when n is 1 from infinity? That's not the point. I'm really thinking of these two as like functions of n, so that it's equal for any value of n. You can even put fractions in there, and the two sides still should match. I'm really trying to make these two sides equal as functions of n, right? And then what's the other number you want to plug in?
0.
N equals to 0. So 1 is equal to, when you plug in 0, that's just a equals to 1. So what that means is this is 1, and this is negative 1, right? So that this thing is really same as summation of n equals to 1 through infinity of 1 over 1 plus, actually, 1 over n minus 1 over n plus 1. I just moved the minus here. Those two things are the same. Now let's try to write it out and see what happens, okay? So you have, when n is 1, it's 1 over 1 minus 1 over 2, plus, when n is, and the next number n becomes is 2, right? When n is 2, you get 1/2 minus 1/3, plus
1/3 minus 1/4.
Let's just write one more. Okay, so what about this? Do you see something now? What was it?
You have a negative 1/2 plus 1.
These two cancel and these two cancel.
You're left with 1 minus 1.
1 minus
1/5, that's 1.
So everything cancels except
Negative
1.
1. 1 is the only thing that survives after canceling everything, right? Now, such a series is called the telescoping series, is because you know, in pirate movies, the pirate climbs over the crow's nest and then has this telescope that expands, and when he sees something, there's nothing there, he folds it back, right? So that's like this. So you have many things that you fold it, and you get something simple. That's telescoping. Let's try the second example. Now, how would you write this as a sum of two things? How would you break this up when you have a log?
Oh, ln of n minus ln n.
Yes, division inside the log becomes a subtraction, right? Oh, notice that I started n from 2. It doesn't matter. You can put any integer here, even negatives. Okay? So when n is 2, it becomes 2 over 3, ln of 2 over 3. But they can be written as summation of n from 2 to infinity of ln of n. And then minus ln of n plus 1. And now let's try to write it out and see what happens. You have ln of 2 minus ln of 3, right? Minus, actually plus, ln of 3 minus ln of 4 plus ln of 4 minus ln of 5, and so on, right? Okay, so what do you see now?
All that's left is ln.
Everything cancels and your answer should be ln of 2. However, there's something funny about this answer. What is ln of 1? 0 is 0, right? So ln of 2 would be bigger than ln of 1, which is 0. So this is a positive number. On the other hand, n over n plus 1, is this bigger than or less than 1? The numerator is less than the denominator, so this must be less than 1, which means ln of these is less than ln of 1, which is 0. So this is a negative number. So you have all these negative numbers and you add them up, and you got something positive. Can that happen?
I guess so.
No way. If that's true, then math will break down. Yeah. No way. Negative numbers cannot be positive numbers. So something's going on here.
Undefined.
You can find an error?
No, I'm just saying it's undefined.
All right, yeah. So your argument is that since if it's true, math will break down, therefore the answer must be undefined or something like that. Okay. But here's when the definition of infinite series comes into play. So I noted earlier that the infinite series, n from 1 through infinity of an, is defined as the limit of the partial sum, right? Capital N infinity, sigma n equals to 1 through capital N of an, right? And therefore, to really know what's going on, you have to say this limit ln of n over n plus 1 has to be written as ln of n minus ln of n plus 1, but you want to only calculate the partial sum and then take the limit. Now let's see what happens to this much. Well, this will be like this, but there's a place that ends, right? What's the last term this would be? ln of, when you have capital N plugged in?
N minus 1. Big N minus 1.
Big N, and then minus ln of big N plus 1. That's the last one, and if you had a series that's like this, with this being the term final thing, then everything will be in between will cancel, but the very first and the last will survive, right? So this would actually be the limit of n going to infinity of ln of 2, the very first one will survive, minus ln of capital N plus 1. And when n goes to infinity, what is ln of infinity? That's infinity. So this is really ln of 2 minus infinity, which is negative infinity. And of course, this makes sense because you're adding negative numbers. So if it adds to negative infinity, that makes sense. Which means that I kind of cheated here. This was an incorrect solution. What's the correct solution? You should really think of this as a limit, capital N of the partial sum. And this partial sum ends with what? When you plug in capital N here, that's 1 over capital N minus 1 over capital N plus 1. Everything in between cancels, and you have a limit of capital N going to infinity of 1 over 1 minus 1 over capital N plus 1. And when this n goes to infinity, that becomes 0, and you get 1. So the answer was correct, but the way you get the answer was not correct. You really have to write it like this. Or else, if you just simply cancel, you might end up making an error that we had here.